I'm going to do question 15 from exercise 6E. So we're told that there's a geometric term, a geometric series or sequence or progression, all means the same thing. The first term is 1, the second term is 2 cosine x. And we're given this restriction on what x is allowed to be. So what I would like you to do is think about what information we have. We're asked to find the values of x for when this series is convergent. So hopefully you remember what convergent means. Means it's always approaching something without ever getting to it, right? So if you halve something, halve something, halve something, halve something, you're always approaching 0, but never ever getting there. So that means we should have some information about what r is allowed to be. R is allowed to be between -1 and 1, because that means we're multiplying by something less than 1, and we're getting smaller every time approaching something. So then what do we know about R? Well, hopefully you remember from a geometric series, it's always one term divided by the previous term. So 2 cosine x divided by 1, which is just 2 cosine x. So this is R. And we know that R must be less than, sorry, cosine x, isn't it? Cosine x must be less than 1. Now, I know it can't be here because I'm told it must be bigger than 0. So I'm going to ignore this part and just focus on this bit. So then cosine x is less than half. Now, the interesting thing about inequalities is I need to flip this when I'm taking the inverse, all right? So now I'm going to say that x is, well, and remember, we are in radians, so I must have my calculator in radian mode. So x is greater than pi on 3. All right, so now what I can do is this is not my final answer, so don't stop there if that's what you think. I've been asked to find the set of values for which x makes this series convergent. So that is just one end of it, but because of this restriction, I need to be more specific. So I know that x is going to be between two values. X must be between pi on 3, but I'm not allowed to be any greater than pi on 2. So this is my final restriction for the values of x, which makes this geometric series convergent. All right, I hope that helps.